So I'm going to do the last part first, why the derivative does not exist. I'm going to do it graphically, and then I'm going to do it numerically with the function. First of all, graphically, if you graph the cube root function, so y equals and then math cube root of x, and take a look at the graph. So it's completely continuous, that's not a problem. But if you zoom into the origin, because the question is asking about at the origin, you'll see that the function ever so briefly at the origin looks like it goes vertical. And vertical lines have no slope. And since the derivative is slope of a tangent line, if it's vertical, it has no slope. So that's one reason the derivative doesn't exist. Now we'll take the derivative and find out what happens at 0. So I'll use the definition, take the limit as x approaches a, and then it's basically rise over run, so it's going to be substitute x into the function, and then substitute the number a into the function, and then subtract the two x values. Well, if you substitute an a in there, it's going to give you division by 0, and also the numerator is going to be 0, which means we need to do some algebra. And what we need is an x minus a here and an x minus a here, so that they can cancel, getting rid of that division by 0. So in order to get this to be x minus a, I'm going to need to multiply. Usually when it's radicals, you multiply by the conjugate, which means use the same thing except a plus right here. But if I used a cube root of x times a cube root of x, that's not going to get rid of the cube root. So cube root really means x to the 1/3. So then I have to say, well, what do I have to multiply with so that it just becomes an x? And what's missing is a 2/3. So if you multiply those, you need to add the exponents and it becomes x to the 1. So I should use x to the 2/3 minus a, conjugate changed the sign, plus a to the 2/3, and do that for the numerator and denominator. And then when you multiply this out, we'll have the first one times the first one, which is this right here, so that's just x. We would have the last one times the last one, so that does the same thing. It gets rid of the radical, giving you just the a, and of course it's minus. And then as far as the middle terms, it doesn't matter, because in here, whatever that a and that x turn out to be, that's negative. And when you multiply these two, it's the exact same thing except positive, so they're going to cancel each other out. So the numerator is done. And then for the denominator, just write it as x minus a times this thing over here. And then exactly what we needed, the thing that was causing trouble, has now been eliminated. So now we can substitute that x becomes an a. So we would get a 1 for the numerator, and then a to the 2/3 plus a to the 2/3, or in other words, 2 of them. So 1 over 2 a to the 2/3. Or if you prefer, it's going to be the cube root of an a squared. Okay, so there's the derivative. And then for the other reason that the derivative does not exist is because if a were equal to a 0 now, it would be 2 times the cube root of a 0 squared, and then that's division by 0, so that does not exist.